Okay, continuing on with our probability unit, we're going to be doing what's called permutations and combinations. These, kind of pay attention to what I'm saying. Permutation says that order matters. The order in which something is put down matters. A combination is saying the order doesn't matter. So you really have to pay attention to that. One of the things I always say, like a combination, you always say a locker combination. Well, doesn't the order of your combination matter the way you put it in? So it's not really a locker combination. It's actually a locker permutation because the order in which you put the numbers matter. Okay. So I'll try to clarify it as we go so that you have a better understanding of when order would matter and when order wouldn't matter. And there are formulas for both of them. Okay, so let's start with this one. The Reyes family will visit a complex of theme parks during their summer vacation. They have a 4-day pass good at 1 park per day. They can choose from 7 parks. How many different ways? Now, this sounds like an outcome, but what changed is this word. When we did total outcomes, it was just how many different ways could you get your ice cream, or how many different ways could you order your sandwich. It didn't say how many different ways can they arrange. Because when it says the word arrange, then I'm talking about a permutation where the order matters. Because I want you to think about it. Once you decide to use one of the passes, so let's say we're going to Disney World. Once you decide that on day 1 we're going to go to Universal, day 1 is over and done and you use the Universal ticket. Done. So that was your first choice. Then your second choice could be that you're going to go to Epcot Center. That's your second choice. Done. You're arranging it in an order and you can't switch it. So this is what we call a combination, and it's a combination that you have 7 choices and you can only choose 4 of them. So I want you to notice a couple of things. The first number is always going to be your larger number. The second number is always going to be your smaller number. And it's always going to be, this is how many choices you get to choose, and this is the total number of choices that you get to choose from. This number is really important because that number tells me how many lines to draw. Like that. This number tells me what starts on the first line, and then I'm going to count backwards. So I'm going to go, and it's always multiplication, 7 times, now I only have 6 parks to choose from. On day 3, I only have 5 parks to choose from. And on day 4, I only have 4 parks to choose from. So again, this is day 1, day 2, day 3, and day 4. So all you're going to do is you're going to take and multiply 7 times 6 times 5 times 4, and you get 840 different ways to arrange how you choose your parks. You better start thinking now because that's going to take you a while if you're going to sit down and try and figure it out. So again, the first number will always be the larger value. The second number tells you how many lines to make. That's how many choices you get to make. This is how many choices you get to choose from. And then you count backwards with your numbers. Okay, you'll catch on. All right. How many different 5-digit numbers can be made from the digits 2, 4, 5, 8, and 9 if each digit is only used once? This is a key word that tells you it's a permutation and order matters. Because doesn't making a number matter how you arrange the numbers? Because if I started off with 9, my number is going to be bigger than if I started my number off with 2. So the way in which I arrange numbers always matters. And if the arrangement matters, it's a permutation. So how many things do I get to do? It's a permutation of 5, comma, how many choices do I get to make? 5. Okay, so I have 5 numbers to choose from, and I get to choose 5 of them. So this tells me how many lines. 1, 2, 3, 4, 5. This tells me what to start with and count backwards. The first, I have 5. Remember, you only can choose it once. So when I first start off, I can choose from all 5 numbers. Once I use one number, I only have 4 numbers left. Then I only have 3 numbers left, 2 numbers left, and 1 number left. So this is a complete factorial, is what it's called. When the numbers are the same like that, you have a button on your calculator that looks like that. This symbol means factorial, and that's in your math book, and I'm going to talk about it some more in a second. I can show you where it's at on our scientific calculator, our graphing calculators. If you have a different calculator, you might need to look for it. It's under the math key. So I hit math key right here, and see where it says PRB? That's probability. Right there. There's that symbol right there. It's the factorial. It's number 4. So you want to hit the number first, then you're going to hit the math key, go over to probability, and go down to number 4, or just type in the number 4. And it says 5 factorial. So that's 5 times 4 times 3 times 2 times 1 is 120. If you don't believe me, watch. 5 times 4 times 3 times 2 times, I don't really need to do times 1. So see, it's just a faster way to do, and it's called 5 factorial. So you have 120 different arrangements. Okay? All right. How many ways can 5 runners be arranged on a 3-person relay team? Well, whenever you're doing a relay team, order matters, because once you put somebody in the first place, that matters. You used that person and you used that place. Now you have the second runner, and then you have the anchor runner. So it matters the order that you put them. So this becomes a permutation. And again, keyword that usually defines that order matters is this. Remember what I said, you have 5 runners to choose from. You get to choose 3 of them. The small number tells you how many lines to make. The large number tells you what to start with. So in the first place, I have 5 runners. Now in the second running, I have only 4 runners to choose from. And then in the third place, I only have 3 runners to choose from. So you have a total of 60 different ways to arrange that relay team. So try to do this one, put it on pause. So this is how you do it. It's a permutation because whenever you have to create a number, the way you arrange the numbers matter. You have 2 lines. You have 6 numbers to choose from, and you get to pick all 6 of them. So this makes this a 6 factorial. So once you do 6 factorial, you get 720 different ways to arrange it. There you go. So that's permutation. These are your factorial. So this is just practicing how to do factorial on your calculator. So 12 factorial is just the countdown of multiplication from 12 all the way to 1. So I'm just going to go quickly through these. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. How many ways can a window dresser choose 2 hats of a fedora, a bowler, and a sombrero? This one, it doesn't matter how you choose those hats. All you're doing is walking up to a hat display and saying, okay, I'm going to take this hat, and this hat. I don't care if you choose the bowler first, the fedora first, or the sombrero first. It doesn't matter. If the story said, choose the hats and arrange them in a display case, then it becomes a permutation where the order matters. Because once you put first one in the first spot, the first spot is taken. This is, you're just picking them. That's all you're doing. So this is what we're called a combination. It's similar to what we just did, but it's got a slightly different formula because it doesn't matter if you choose a fedora and a bowler or a bowler and a fedora. I don't want to count that as two separate things. It's one thing. So I need to do some division in this to get rid of doubles. So again, the first number is the bigger number. That's how many I get to choose from. I got 3 hats to choose from. I get to choose 2 of them. So again, this tells you how many lines. The only difference is I got to get rid of the doubles. This also tells you what you're going to divide by in order to get rid of the doubles. So what goes on the first line? The 3. I have 3 hats. Once I choose a hat, now I only have 2 hats. So your problem becomes 6 over 2 factorial is just 2 times 1. So 2, which is 3. So let me show you the picture that they're going to give you. So first, look at that. So look how it's different. If it was a permutation, I would have just did 3 times 2 and my answer would have been 6. But it's a combination because there's no word in here that says arrange. It's just you're choosing. It looks like this. So here are your choices. And this is where I'm saying to you, it wants to get rid of the doubles. This and this is the same thing. Okay? This and this is the same thing. And this is the same thing. So you don't want to count your doubles in this. So that's how come you had to divide it by the factorial. Okay. I want to change this one because I don't like that it always says 2. On this one, let's say that we get 3 shirts. It says, how many ways can 3 shirts be selected, keyword, from a display? It's not asking you to display it. It's just asking you to select it. It's not asking you to arrange it in an order. It's just asking you to walk up and grab the shirts. So that's what makes this a combination. A combination where it goes 1, 2, 3, 4 shirts to choose from. You get to choose 3 of them. So your formula is this, it's a division, this on the bottom to get rid of your doubles. This also tells me the number of lines. This is what I start with. 4. First I have 4 shirts to choose from. Once I chose a shirt, now I only have 3 shirts to choose from. Now I have another shirt, so now I only have 2 shirts to choose from. So 4 times 3 is 12. 12 times 2 is 24. And then 3 factorial, remember, is 3 times 2 times 1, which is 6. And so there are 4, in this case, different ways. Now remember, when I show you the answer here, it's going to be different because I changed it from 2 to 3. So make sure you really pause and look at what I just did there. This is why I changed the 2. Okay, let's make this one 4. Okay? How many ways can a customer choose? Again, you're just choosing, not arranging it. So I have 1, 2, 3, 4, 5 different pens. I get to choose 4 of them. I was cutting myself off there. I have 5 pens and I get to choose 4 of them because I changed this to be 4. And it equals, put your line, put this underneath to get rid of the doubles. Put your 4 choices down. First I get to choose from 5 pens. Now there's 1 less pen. Now there's 1 more pen. And now there's another less pen. And then you have your total. So let's do 5 times 4 times 3 times 2. You're going to get 120. Divided by, remember 4 factorial is 4 times 3 times 2 times 1. So 24. So then you're going to do 124 divided by 24 and you're going to get 5. So you have 5 different combinations that you can choose. 5 pens. 4 pens from 5 choices. How many ways can a student, see how they keep picking two? Students select 2 books from a bookshelf containing mystery, so on and so forth. You're just choosing them, you're not arranging them. So it's a combination of 1, 2, 3, 4, 5 books. You get to choose 2. Combination, 2 factorial. You have 5 books to choose from. Now you only have 4 books to choose from. It becomes 20 divided by 2, or you have 10 different ways to make that combination. Here you have 2 vertices. You have 2, 4, 6-sided figure, so a combination of 6, 2. Doesn't matter which way you connect them. 2 factorial. You have 6 choices. Now you only have 5 left. And you have 15 total combinations for that. Same kind of thing. This time it's a pentagon. Of course, you remember a pentagon is a 5-sided figure. So it goes like that. 5 times 4 divided by 2 factorial. Don't forget that bottom is factorial. I know 2 factorial is 2, but it's not always going to be 2. So again, 10. Yay! Good luck.